everywhere. All right. So the first thing we're gonna do, maybe it's the TikTok servers again. So let's do it. Let's do it. So we do 1, 2, 3, 4, and then we go here. We go live and then live. Right. So what we're gonna do is we're gonna count. Here is 0. So 0 looks like this. Because 0 looks like that. Let's see. Go to groups. Go to share. Hello, hello, welcome. So what we're doing is we're learning how to read the abacus, and hopefully you guys can hear me. So this is 0. So after 0, this is 1. After 1, right, this is 1. How do I know that this is 1? Because if you look at the horizontal bar, the bead is touching the horizontal bar. This is the horizontal bar, and this is the horizontal bar that counts the abacus. So you notice that this is 1. So now when we look, this will be 2. Here is 2. So when we look, we have 1, 2. All the horizontal beads is touching this horizontal bar. Because they're touching like this, that's what's being counted. So then we do 3. Notice that this is 3. 1, 2, 3. 1, 2, 3. And then we have 4. 4 looks like this. There's a picture of it, and here is what it looks like. So we have 1, 2, 3, 4. And then, do I have 5? Uh-oh. Oh, I should have 5. I should have 5. Yep, there we go. I have 5. Now, what does 5 look like? 5 actually looks like, with the top bead, 5 will always have a top bead. 5, when it touches the horizontal bar, is being counted. Notice that none of these are being counted. That's because these are not touching the horizontal bar. The horizontal bar is what tracks the beads. So what we're doing is we're looking at the abacus and we're learning how to read the abacus. When we learn how to read the abacus, we are looking at it 5. So then we count, that's 6. So here it looks like 6. And then 7. 7, and then 8. 8 looks like this. 5, 6, 7, 8. Notice the top bead has a value of 5. The bottom bead has a value of 1. So this is 1, 2, 3. Because they're together, then together like this, they are considered 8. Ah, thank you for the lightning bolt, Mark. Welcome. Hopefully you have questions about the abacus. So let me know if you have any questions about the abacus. And then we have 9. So 9 looks like this. 5, 6, 7, 8, 9. Thank you for the hearts. Thank you for the hearts. And I'm hoping that TikTok servers are going well because I did it earlier today and it was like kind of wonky. Anyways, so we have 9. And then what do we have is 10. Do I have 10 here? Do I have 10? Yes, I have 10. So if I look at 10, that's what 10 looks like. 10 has a 0 and a 1. Just as we write 0 and 1, that's what it looks like. 0 and 1. So this is what 10 looks like. This is my ones place. Now when you look at it and we have our handy dandy little place holder name thingy, we have our ones, our tens, our hundreds, our thousands, and our 10,000. So when we look, this is 10. And then we can count by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90. Notice that 90 looks like 9. It's just the only difference is that it's a different place value. That's all. Anybody have any questions, let me know. And then what we're going to do is we're going to talk about hundreds. So this is hundreds. Now, if you see, we have 1. Notice the 1 and this 1 looks very similar. So when they look similar, but the only difference is the place value. So when we look, we have 10. This is what 10 looks like. 10 and then 100. 100 would look like that. So we have our ones, 10, 100, thousands, 10,000. Let me know if you have any questions. And now we can count by hundreds. 100, 200, 300, 400, and then 500. Notice the top bead always has the top bead is always a value of 5, no matter what. Because the top bead is a value of 5, right? We have 500. So then we can count after 5 is 6. After 6 is 700. 700 because it's 700. 8, 800, and then 900. So we have 900. So right now we have 900. 900, and then this is 9,000. How do I know that this is 9,000? Because we have our 9. 5, 6, 7, 8, 9, and then this is the thousands. When we look at our columns, we have our ones, tens, hundred, thousands, 10,000. Notice I have a decimal The decimal sits between the ones and the tens. Does that make sense? So because it sits between the ones and the tens, it doesn't have a place value. What the place value is the ones, tenths, and then the hundredths. What a crazy name. I don't know why they would do that. But anyways, so that is the difference. Anybody have any questions? Do you all understand? Are we tracking like a horizontal bar? Are we good? Are we good? Yeah? Make sense? So when we count, we're going to count again. 1, 2, 3, 4, and then 5, 6, 7, 8, 9. Thank you so much for the hearts. Thank you so much for the hearts. Does anybody have any questions? Because I want to know is if we look at this, what number do you think this is? What number do you think this is? Put it in the chat what number you think this is, because it would be interesting to see if anybody's sleeping in class. Hopefully nobody's sleeping in class. So let me know. I have, what number do you think this is? Hello, Destiny, and RW4, and Marcus, and Rock, and 29. Yes, Vapor. 802. Right. That's what it is, 29. And inside your username is 802. So it's 802. That's what that would look like. On the Abacus, that's what it looked like. Why? Because we have ones, or tens, or hundreds, our thousands, and our 10,000s. So when we look, we have our decimals. Why am I here? I'm here because I have this indicator. This indicator tells me that this is the ones place. So this is the ones, then we have our tens, thousands, tens, hundred, thousands, and then 10,000. Let me know if you have any questions. And so we can continue on. After that, we have 10. Well, we have 10. That's what 10 looks like. And then this is what 11 looks like. That's what 11 is. After 11, right, is 12. And that's it. That's it. That's it for my pages. So anybody have any questions? Let me know. Hello, Sue. Okay. So again, we're going to count again just so we know how to read the abacus. You know what? I'm going to give you a number. I'm going to give you a number. Oh, no. You know what? I'll give you a number. Nah, 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 nah. That. Okay. So here's a big number. What number do you think this is? Let's put it in the chat. What number do you think this is? If I have my ones, my tens, my hundreds, my thousands, what number do you think this is? Whew. Anybody know what number this is? So Vapor mentioned, and then just kind of checking. Wow. Okay, let's see. 1,000. Hey, Dandelion, welcome. Destiny says 9, 5, 7, 4. Yes, Vapor. Yes, Destiny. Yes, Cat. Yes, that's what it is. 9,574. Make it easy, right? Super easy. So if we're ready, we can start talking about a little maze that I created. So we can go through this maze just to do some more bead recognition. So in this one, what the idea is that if we start here, what number do you think this is? I am going to color it in, and that was the idea, to have it all colored in. So this would be the hundreds, right? So the hundreds, so it would look like this, and then that. So what number, Destiny, I just added an extra 5. Yeah, but I understood though, because it's probably fat thumb, right? Vapor, it's probably a fat thumbing thing. But you got the numbers. I finally understand. Yeah, right? Easy, right? Simple to use. So what number do we think this is? Thank you, Kat. Yes, great. I'm so happy you guys are getting it. And then we start to dwindle, but that's okay, because we're going to go through the maze. We're going to go through this maze that I created, and this is part of the book that I'm going to be publishing pretty soon. The idea is to do some bead recognition. So if I have this number, I have 5, 6, 7, 8, and then, oh, you guys, yes, 5, 6, 7, 8, and then 1, 2, 3, yes, 888. So I'm going to color it in. I'm going to follow this box. So the next box is what number? Maybe I should just do this then. So if I have this, what is my number? Maybe I should do that instead. Okay, so what number do you think this is? This abacus mimics this box, just so you could see the correlation. And the reason why, so then you could see what it looks like. 3, 5, 7. Good job. Good job. So we're going to go this way, right? Good. Are we okay? Make sense? So we're only doing 3 digits right now. So if I look at my 3 digits, I have this number And then the idea is to color it in, right? And then I have this number, and then I have this number. Well done. Destiny, Chris, Vapor, Cat, and Chris again. Okay, so what number do we think this is? Hopefully, the TikTok servers are corrected. All right, Destiny says 5, 6, 2, 8. Yes, 8, 6, 2. Good job. So it's 8, right? 5, 6, 7, 8, 6, because it's 5, 6, and then 2, 1, 2. Exactly. So we're going to go over here, and then we're going to go to the next one. So here's the next box. The next box is 5. So if I do this, and then that, and then that, what number is the next number? Wow, I'm already at 1,000 likes. Thank you guys so much for liking the live. So we have this number. What number do you think this is? We're talking about this one right here. And it looks like on the abacus. 78. Ooh. Well, we have to remember that there's a 0 here. So you're very close, Destiny. It's actually 700. Yes, there you go. 780. You're absolutely right. Probably a fat thumb thing. Hey, Ashton, thank you. Yes. So it's 780. Why? Because we have 7, 5, 6, 7, 80, 5, 6, 7, 8. And then don't forget, this is our tens. So when I look at it's our hundreds, our tens, and our ones. Ones, tens, hundreds. So then we have this number. And then this number is, we have this, and then that, and then this. What number do we think this is? 610. Yes, good. Makes sense, right? 610? Yep. Great. Thank you, Destiny. Thank you, Ashton. So we're going to keep going. We're going to go all the way to the end, and then after that we can start doing our adding and subtracting and multiplication and division on the abacus. How would you do division problem when the answer's in the decimals, or does it have, or has a remainder? Well, if the answer has a decimal, well, you just use it as a decimal. It's not the answer that's the problem with the decimal. It's the divisor that has a decimal. So when you see the remainder would just be the remainder like everything else. It's just long division, just on the abacus. 4, it is 4, 1, 2, 3, 4. That we have to remember. And then we have 5, 6, 7, 8, 9. Some people forget the 5. Some people forget the 5. Yeah, that's very good, Destiny. So did that make sense, Cakes? 6969? So, oh yeah, so we do this. So what's going to happen, can you show it on the abacus? The decimal? So if I did decimal, right, this is 459.56. That's what the decimal would look like. That's it. We can do division, but it would be after we do a little bit of multiplication. So if you want to stick around, that'd be cool. But for right now, what we're doing is we're doing some bead recognition. So we have this 9, 5, 6, 7, 8, 9. Oh, did I do this one already? Oh, I did this one already. I did that one already. Yep. Ashton, yes, thank you. And 6. Oh, did I? 8, 5, 8. Okay, got it. So then what's our next one, right? Our next one is 3, right? 1, 2, 3. And then we have this number. Right. Oh, good. Ashton and Destiny, good job. Well done. So we have 7, right? 307. So I'm going to go up, and then we're almost done. So we have this one. What's our next number? Our next number is, if we do this, 1, 2, 3, 4, and then we have this, and we have this. So we have 4, and then that. What is this type of abacus called? I only use or seen the big ones. Oh, hey, honey. This is called a Soroban. Thank you, N6. A Soroban is spelled Soroban. A Soroban is a Japanese abacus. Great, N6. Fantastic. Destiny, you okay? You all right? So we have this one, and then we have this one. So we have 1, and then that, and then that. Okay, good. Good. I want to make sure we're all still on the same page. We're almost done. So what's the next number? Honey, did that make sense? It's called a Soroban. It's a Japanese abacus. Ashton says 195. Yes, great. So we're going to do that. And, oh, and then we do this. Yes, thank you, Destiny. Yeah, that makes a lot of sense to count with. Yes, there is another one called a Chinese abacus, and a Chinese abacus is spelled suopan. But I don't teach that. We have this number. N6. It's a 1, not a 4. How do you use the abacus? Well, right now we are learning how to read the abacus, Becco. So, good. Thank you guys. So what we're going to do is we're learning how to read the abacus. This is what we're doing is this is what it is, 60, 86. So then this is our final answer. While everybody's else answering, I will answer your question, Becco. So when we count, we do 1, 2, 3, 4, and then we have a value of 5 is up here. The value of 5 will always be the top bead. Hello, Brandon. So then this is 5, and then this is 6, 7, 8, 9. Does that make sense, Bucko? Yes. It's 406. Yes. Got it. 1, 2, 3, 4, and then that's it. 406. Yay! Okay, so what's going to happen is this is 9. When we look at it, Becco, when we look at it, this is 9. And when we have our tens, we have our ones, our tens, our hundreds, our thousands, our 10,000. Now what we're going to do is we're going to count by 90. This is 90 because why? This is our tens and this is 9. So not 5, 6, 7, 8, 9. So we can just continue to count. Thank you for the follow, honey. When we count it, we do 1, 2, 3, 4, and then 5. The top bead will always be 5. If we want 10, we don't do this. This is 55. Why? Because this has a value of 5. If you want 10, it would look like that. So this is the same as that, just in a different column. When we look, it is ones, tens, hundred, thousands, 10,000. So we have 1, 10, 100, 1,000, and then 10,000. Now, because we did a little bit of exercise of how to read the abacus, we're going to go into learning how to add and subtract. Are we ready for adding and subtracting? Because the biggest thing is to understand how to read the abacus. Why? Because if you don't understand how to read the abacus, then it's really difficult to catch up with when we're doing some adding and subtracting. We're actually going to start doing some formulas. The last two, yes, you know what? That is Atticus. Excuse me, did you say my name? No, I did not. But I just did now. Okay. Yes, N6. That is fantastic. I'm so happy that you recognize that the 2 are the decimal. So that means is we're called it the ones and the tenths. So we have the ones and the tenths. Notice that the tenths, I wish you were my math teacher. You just explained that so easy for me to understand. I scrolled by and you said my name. Oh, okay. Welcome, Atticus. Welcome. Okay, so when we look at it, notice that the decimal does not sit on a place value. So the decimal does not sit on the place value. It sits between the columns. That is why we do the ones, and then there's the decimal, and then there's the tenths. So as we look, we have the tenths, and then we have the hundredths. We choose this indicator as the ones. You could, if you wanted to, choose this one. You just have to shift everything over. So our tens and our ones, our ones and our tens. But notice I don't have any hundreds because I decided to choose this, like a Pokemon, right? We're choosing Pokemon. I choose you, and this will be my ones. So when we look at it, we want to make sure it's all about perspective of life, right? Where do we want to put our home? Where do we want to put our ones? So if I had a bigger abacus, like this is a 13 column abacus. This is a 7 column abacus. Notice with my 13 column abacus, size matters. And it's all about the decimals with the locations of the indicator. Look at it. There's 1 here, 1 here, 1, 1, 1. So if I started here as my ones place, man, this is uncomfortable. It's going to get worse because we're going to talk about the national debt. So what's going to happen is if I have the ones here, right, this is my ones, and just as I line it up, I have my ones, my thousands, my millions, my billions, and then my trillions. So when I look at it, right, I can talk about 13 digits. my digits are 13 digits, right? I believe the trillions is where the national debt is, but the problem is there's not enough digits for the national debt. So what happens is there is a 23 column one. So with this 23 column, we can actually track our national debt. Yeah, 23. But I've had this one for a while. This one's made out of bamboo and it works exactly the same as the plastic one. It's just the plastic one's more new. That's all. And it works exactly the same. It's supposed to be really free flowing. If you notice, it's like a little rattle. So that's why when you work with the abacus, you want to make sure that it's stationary. If it's when it's stationary, then you won't lose your answer. The problem is if it moves too much, because that's my problem, is like I move the abacus a lot, I might have the wrong answer. It's kind of like an instrument. Yes, you know what? It could be an instrument. It could be a race car. Right? It could be a race car or it could be a massager. Some of the kids do that. It gets a little annoying, but it is what it is. So this is a 23 column. You could get this one, but I do believe it's a little bit of a penny. And this one here, I like it because I'm getting a little lazy now as I get older, and I can actually use this as a reset button. But this one you can reset as well. All you got to do is not flip it, but tilt it and then move all the beads top, and that's it. Thanks for the refresher. I haven't seen this since grade school. Ooh, Vapor, really? That's fantastic. You did the Soroban when you were a kid? That's kind of cool. I've been working with the abacus for about 20 years now, and there's not very many people that remember the abacus or even know what it is. So the first thing we're going to do is, okay, we've talked a little bit about the abacus. Now what we're going to do is we are going to do some adding and subtracting. So as we add and subtract, we will notice that in Abacus, we focus on the add-in and not the result. So it's all about the process, not about the destination. What is it? It's, what is it? Marry the process and, what is it? Marry the process and divorce the result. It's all about the, good, you are teaching. Yes, thank you. I think this is all I do is just teach. All I do is just teach the abacus. This is how we're doing it. This is what we're doing. We're learning how to do the abacus. Why? Because we want to know is how do we add the abacus? I grew up with a small island in Vermont. Oh, interesting. Hey, Jay, welcome back. Yeah, this morning. Oh my God, I was so tired after my last one. I took like a 2-hour nap, man. Holy cow. I didn't realize I was so tired. All right. So the first thing we're going to do is understand that we're going to look at I love seeing the Chinese drama, but never understood it. Ah, that's funny. Oh, the Chinese one is different, though. This is the Japanese one. The Chinese one actually has 2 digits, 2 columns. So 2 5s on top and then 5 beads on the bottom. So when you look at it, it counts exactly the same. We have 1, 2, 3, 4, 5. And then here we have to trade it in. We have to trade the 5 for the top bead. The top bead will always be 5. I saw one of your pages that shows the format, but I can't find it. The format. What format? I don't know what you're talking about, Jay. Let me know. Let me know because I have a lot of pages out there. All right. So we have 5, right? And notice we can do the same thing. That's 5 on the Soroban, the Japanese abacus. When we look at it, it's exactly the same. 6, 7, 8, 9. And on the Chinese abacus, we do 6, 7, 8, 9, but notice we can do 10. Now, because we have 10, this 5 needs to be traded in. So this 5 goes to up here. I think it's a little redundant because what happens? Now you got to trade this in. The if-then format. Oh, oh, I didn't post that yet. I will publish that. So, hold on. I never posted. Does anyone know why she keeps saying my name? Ah! That's funny. I get it now. Okay, so that's funny. All right, so here we want to trade. We want to trade this 10. We want to trade this 10 to this number over here. This is going to be now here. Why? The reason why is because this breaks my brain. This breaks my brain. Why? Because this is no longer part of the tens. This is now, that doesn't make sense to me. So, but this makes more sense because now we're talking about place values. Every time we say, now I don't want to say it anymore, Atticus. So now if you notice, this is my 10. This is my ones, my tens. This is my ones, my tens. But thank you so much for letting me know. Which do you prefer using of the two? I actually teach the Japanese one. This is the more modern one. The Chinese one is Atticus. The Japanese one is more efficient and it's also more modern. So when you look at it, the Chinese abacus was before the Japanese one. So in the timeline, is it as it works the same? It's just there's no competitions for the Chinese one. There's competitions for the Japanese one. There is no like society for the Chinese one, which is interesting. However, there is a society for there's like an international agency or whatever that does the Japanese one. And if you notice this one, when you go to the YouTube and you do a search for abacus. No, Chinese didn't invent it, actually. It was the Mesopotamia. Like, it happened long time ago. Like, when we started working with business, when we started doing, instead of trading, they started using money, like currency, like, what is it? It's called Mesopotamia. We did the trading and the bartering. So after they started putting in money, that's when they started doing it. The word abacus actually just means moving the beads. So it doesn't matter what you have. They're all the same. The abacus all work. It just depends on how that's being used, if that makes sense. Yeah, not a problem, Vapor. But people think that the Chinese people have created it, but we didn't. But they made it more efficient, and then again, it got more efficient. So we all learn from everybody, right? Okay. So we're going to do is we're going to understand how to read the abacus. The reason why is because we want to focus on the add-in, not the result. Because why? When we start looking at the questions, we won't know what the answer is. This is the way. In abacus, in the abacus world, we notice we actually have more common. It's common to have questions with more than just two add-ins. Did the paper? Did the paper? I don't know what you mean. So what's so what's going to happen is we're going to do the one, right? I'm sorry. We're going to have six. Not here. We're going to have six. When we add one, we want to just add the one beat. The reason why is because we want to know what it looks like to add the one. Did the Japanese one come from Mesopotamia as well? Japanese one came from Japan. It's just a bunch. It's just like it's just like the numbers, right? The numbers. Did it come from? Where does it come from? No, it's not Roman. These are not Roman. These are Arabic, right? These numbers are Arabic, so they came from yeah. So does that make sense? But yeah, no. Um, okay, so this is six. So ideally, what we're trying to do is we're trying to understand how to move the beads. So this is seven. So when I have seven, and I add the one bead. Why? Because all I want to do is add the one bead. All I want to do is add the one bead. When we look at it, we just want to add the one bead, right? We want to understand what it looks like. So then when we look, here's number two. Here we want to add two. When we add two, again, we look at six. And then how do you add two? When we add two, it's one, two. These are the two beads. I do it slowly just so you could see what I'm doing. I just want to move two beads. It can be any two beads. It could be these two beads, or if I had seven, it would be these two beads. It doesn't matter as long as I add the two beads. The idea is just to add two beads. It doesn't matter which one. So when we look at it again, we have the +3. This specific book was supposed to be for I try to add it with like some activities, and you answer the question and then you find your answer on the puzzle piece. So that was one of the things is like this book was meant for young children because we don't have anything out there that is abacus related. So this one is 5. As I have 5 up here, and then I want to add 3. When I add 3, right, because my add-in is 3, I'm just going to add the 3 beads. Notice it's 1 2 3, and I'll do it together, right? I don't want to do 1 2 3. You should be able to do it together because that's what, because it's part of subitizing. Subitizing means that if you see a number, you know what it is. I don't have to count 5, 6, 7, 8. I look at it, I know this is 8. Why? Because I know that this is 5. So we have 5, 6, 7, 8. When we count it, we know that we have 5 and then we add 3. This is now 8. So it's a little bit about decomposing, if that makes sense. Now we have the question number 4. We add 4. When we add 4, there's not a lot of numbers. There's not a lot of questions to add 4. So what's going to happen here? It's either 0 plus 4, which is that, or it's 5, right? We have 5 and then plus 4. And then my answer is 9. Notice, again, it's 5 plus 1, 2, 3, 4, plus the 9. I'm sorry, plus 4. So now, because we know how to add, we will know how to subtract. What does that mean? Well, just as we add, we move the beads up to the bar, right? We move up to the bar. We now know to remove it, to subtract, we just take it away from the bar. I hope that makes sense. I hope that makes sense. So what's going to happen is when I have 2 and I want to take away 1, I do that. I see people do this quickly with lots of numbers very quickly in their heads? Is that what they use? Yes, exactly, Destiny. This is what they use. Because the idea is to imagine this abacus in your head. So when you imagine it in your mind, in your mind's eye, you can move the beads. Can I do it? I don't try, but there are people who can. So when you look it up in those little YouTube videos and there's this, and there's some of the kids are really dramatic and they're like doing this and stuff, they're just being dramatic. They don't need to do that because it's just a flick of a finger, really. It's just a flick of a finger. They don't need to do like hands like this. They don't need to do that. They don't even need to do that. They just do it for, they don't even need to do that. They just do it for presentation. It's all just an act. So here I have my question is 3. That's a very good question. So I have my question is 3, and then I take away the 1. Notice I just take away the 1, right? I take away the 1. All right. So then, again, we just did the same thing. If we add the 2, we minus the 2, right? If I have 4, and I take away 2, all I got to do is take away the 2. That's all I got to do. All I got to do is take away a 2. And then it'll be 3. After that is 3. So I have, what number is this? This is 8. I have 8 and I take away 3. 1, 2, 3. So I take away 3. My final answer is 5. And then we go into 4. Again, 4 doesn't have a lot of questions, right? So I have 4, take away 4. And then what's after 4? Well, of course, we got to do 5. And it's the same thing. When we want to add the 5, we just bring down the bead. We bring down the bead to touch the horizontal bar. So we have to make sure that the top bead is the opposite. If I want to subtract the 5, I remove it, right? If I want to add the 5, and then I want to subtract the 5. Make sense? So this is about adding 5, subtracting the 5. Notice it's balanced, right? If you know how to add it, you'll know how to subtract it. If you know how to add it, you know how to subtract it. And it's going to keep going. And we're going to start building on this. We're going to start building and understand how to do this. So we have 6. We have 6, right? We added 6. When we have this is 8, and I want to subtract 6. Notice I take 1 5 out and 1 bead, and I move it like this. Does that make sense? So now what I'm doing is I'm subtracting 6. So my answer is 2. When do you do math on the fly? Do you picture the abacus in your head? I do. I do a little bit. I don't, I learned this as an older person, so I'm not as quick as my kids. My kids can do it really quick. I've been teaching for about 20 plus years now, but my kids, I have 3 boys and they all learn the abacus, and can they do it in their head? They might be able to, but I don't push it. So it's just one of those things, like I don't push mental math because I don't see it. I don't see what the point would be, because we keep pushing to do mental math and stuff, but it's like when we write checklists, do we write it down or do we keep it in our head? We're always told to write everything out. So doing math mentally doesn't, having calculations and keeping it in long term makes sense to me, because then you can have room to do more complex math. So in the abacus, we'll learn how to do adding, subtraction, multiplication, division, and that will become very easy for you to see on the abacus. But then you can go further into understanding like more complex math, because abacus is the gateway to complex math. But thank you, Brad, for the question. So we had 6, and then we do 7. Obviously, we have 8. So we have 1, and then we have 9. Plus 8. When we plus the 8, we have 5, 6, 7, 8. We bring it together like this. Now, when we want to minus 8, we do it this way. We have 5, 6, 7, 8, and we take it away like that. So notice if I add the 8, now I can take away the 8. what happens after we don't have enough beads. The question is always, what happens when you have enough beads? So after we understand how to learn how to move the beads, we did some simple addition and subtraction, meaning, do we have enough beads? Yes, we have enough beads to do the calculations. Now, what happens when we don't have enough beads? Well, that is where we start coming into understanding this thing called the fact family. This fact family is very interesting because we're teaching children how to add 4 plus 1 is equal to 5, or 1 plus 4 is equal to 5. Why does this matter? Well, now what we're going to do is we're going to understand that we will have some hardworking numbers. We don't have any freeloading numbers. Why? What age did you start teaching your kids? I started at 4, 3. I'm trying to reach 3-year-olds, and it takes about a year for them to actually understand what the numbers are. That's why I built out my worksheets. When I was teaching my kids, I started them at 4, and then I have a learning center that's out in Monterey Park. So if anybody's in the Monterey Park, how old were your kids and you? How old was I? How old was I when I learned it? I was probably in my 30s. I was old. What age is Miss Lena and her kids? Yeah, so when I learned it, I didn't learn it as a child. Yeah, I didn't learn it as a child, but I taught my kids, and my kids learned it when they were like 4 or 5. But as a young parent, you don't have a lot of time, so I didn't have a lot of time to teach and more teach and create worksheets. The kids are old now, so they don't need me as much, so now I have more time to teach everybody else. If that helps. Thank you for the follow. Only smiles. If that made sense. So going back to here, we're learning how to make this 5. When we're going to make this 5, I just learned my target is a counting tool. Yes, yes, your target is a counting tool. It is an abacus. Yes, I appreciate your teaching. Oh, thank you, Jordan. But we're going to continue on because there's more to than just counting. We can add, subtract, multiply, divide, and it's the greatest thing next to sliced bread. But see, the thing is we had to understand how to move the beads. Now we understand how to move the beads. Hey, Glow Girls, you're back. You didn't give me a picture of your abacus. I'd like to see that picture of your abacus. I'm sure it'd be very beautiful because it was handmade. So what we're going to do is we're going to understand what this means. Notice we have a 5. What's going to happen is we need to understand how to utilize this 5. Why? Because this is what we're getting into understanding how to, it's called a formula. Why is it a formula? Well, when we do 4, notice I don't have any more beads to add the 1. I don't have any more beads to add the 1. So what are we going to do? Well, we got to modify this. We had to modify this formula. When we do modification, we don't want to do, I don't want to be stock. That's great. Sorry, I was thinking about Cars Tune and how there was like, Mater went under modification, right? Mater did some modification, and then I was thinking about, well, what's stock? Well, this is stock. We don't want to be stock. I'm stock. Okay, I don't know if you guys know Cars Tune, but that was Tokyo Drift. Anyways, so we have 4 plus 1 is equal to 5. We have 4 plus 1 equals to 5. Now what we're going to do is we're going to, we need to isolate the variable. Isolate the variable means that we want to isolate this 4. We want to make it by itself. The reason why is because the question is 4 plus 4. This is the question. This is the problem that we're having. That problem is going to be solved with this modification. What's going to happen is when we make the 4 by itself, we're going to make it 4 is equal to 5. Notice this is not balanced. Because this is not balanced, I'm going to minus the 1. Now we can substitute this information to our 4. How does it work on the abacus? Well, just as I mentioned, plus the 5, right? That's what this is. We add the 5. Adding the 5 is too much. So what do? We minus the 1. And then my final answer is 8. So in Abacus, we do not memorize doubles. We don't memorize 4 plus 4. What we memorize is the formula. This is the formula we memorize. Does that make sense? Are we all right? Do we want to do another one? We want to do another one? Well, let's do another one. So I have another question. Let me have another question. I have another question. 3 plus 4. I was like, wait, 3 plus 4. Again, if I look at it, 3 and I want to add 4. Thank you, Jay. Hey, Ruben, welcome back. So I want to have 3 and I want to add the 4. When I add the 4, I don't have enough beads to add the 4. What do I do? What do I do? I go back to this formula, plus the 5, and then take away the 1. My answer is 7. So now we just made our numbers work for us. We are utilizing the numbers and the concepts that we have. We're not working with stock. This is the if then? No, not yet. When we do the next one, so we have the 7, right? And we want to add another 4. That's what we're doing. Oh, Jay, let me hold on that one. So Destiny, does that make sense? We're going to do is we're going to continue with adding the number 4. Is that what we want to do? Yeah? Okay. So I'm going to erase my numbers. I'm going to erase my numbers. And what I'm going to do is I'm going to use this book. So this book might be helpful because I made it into a little story. So here, I want to do, oh, wipeable. Yeah, I made it. Yeah, I didn't. Yeah. Anyways, yes, because I'm doing a lot of this. Sorry, Destiny. So when you're working with it, right? We did 3. We did 3. We're adding 3. Now the question is do I have enough beads to add the 4? I don't have enough beads to add the 4. What are we doing? Well, this is where the story comes in. Every time I don't have enough beads, I'm going to go to this cats in a tree. There's cats in a tree. There's always going to be 5 cats in this tree. What? Why? Because this is the way. No, because there's 5 cats in the tree. The 5 cats in the tree is going to be an analogy for this 5 bead, if that makes sense. So if I go to the cats in the tree, I add the 5. When I add the 5, I take 4 cats, 1 cat runs away. So 1 cat runs away, and then I'm left with 7. Did that make sense? Okay. Wow. Hello, Phineas. Miss Phineas. I see, right? It makes sense now. Because I think the story helps. I think the story helps understanding. And so when we do it, and maybe I add the story into the adult version of the abacus. Yeah, because I'm trying to make an adult abacus introduction to abacus for adults. Ha! Hennessy, thank you. Good job. Okay, good. So if I do 4, again, we don't memorize our doubles. What we do memorize is how to use the 4. The 4 formula, right? We don't use stock. We don't use stock. What we're going to use is when we're going to use the equation, the formula. So I go to the 5, to the cats in the tree. I go to 5 cats in the tree. I grab 4 cats and then 1 cat runs away. And then my answer is 8. Okay. So what's going to happen is what? Well, what happens is what happens if we add another 5? Another 4. So Jay, this is what we're doing now is the if else. Now what happens is we want to add another 4. When we add another 4, the question is can we add a 5? This would take time to be able to do fully mentally. Yes, it would. And you know what? I don't even do it fully mental. I'm not mental because it takes a lot of time and it depends on what you want to do with your life. I don't compete and my kids don't compete, so it doesn't, I mean, it's up to you if you want to do it. I do like it so we can do like arithmetic and it'll keep like doing Sudoku. You know how people do Sudoku, crossword puzzles, word searches. I kind of feel like that, doing abacus would keep your brain active like that. And I think that would be kind of cool. What's going to happen is I want to add 4. I want to have 8. I have 8 plus 4. This is where we do the if else thing. Now, we want to add 4. Do we have enough beads to add the 5? That's the next thing. No, we don't because we're already using the 5. Well, what's the next thing? Well, our next, what do you call it? Our next stock, our stock equation is this. 4 plus 6 is equal to 10. So this is where we start utilizing our 10. This is what do people call it? They call it carrying on, borrowing, grouping, excuse me, regrouping, and trading, right? So here we just call it 10. We just call it 10. What does that mean? Well, we're going to do modification again. Notice, right? There's a pattern. You'll see that there's a pattern. I have 4 plus 6 is equal to 10. I'm going to isolate this 4. Looks very familiar, doesn't it? That's my 5. Now this is my 10. So what I'm going to do is I'm going to isolate the variable. I'm going to move this 6 over here. When I move the 6, I'm going to rewrite it. So it'll be 4 is equal to plus the 10 minus 6. That's what we did. So when we look at it, I want to plus the 10. 10 just means I'm going to the next column over. I plus the 10 and I take away the 6. And that's it. That's all I do. So my final answer is 12. Jay, did that make sense? You have to see if you have a 5. If you do not have a 5, then you do the 10. Okay, good. It's the same way. It's always, the first question is, do you have enough beads? Does this help when doing algebra statistics? This helps with algebra. I'm not sure about pre-calc, and I'm sure it's of statistics. But we don't do probability on Abacus. Because why? Abacus is really just arithmetic. It's just adding, subtraction, multiplication, division. And what it is you put these patterns in your head. You put this framework, and you talk about critical thinking and analyzing your questions. That's what you do with adding, subtraction, multiplication, division. Then you can take that skill and you can move it to the others. Have to understand the one bead under the 10 means 10. Yeah. Might need another. Yes, I'll do another example. Every bead has a value. Yes, every bead has a value. But the only thing is you only need to focus on 2 columns at a time. The 10 bead always means the 1. Adding 1 always means. So just like regrouping and grouping. We'll do another one, Destiny. Don't worry. We'll do another one. But I just want to make sure that when you understand, when we add a 10, right? So let's say we had 48. We had 48. Add a 4. When we add a 4, we plus the 10 minus the 6. Plus the 10. Plus the 10. I don't have enough beads to add the 10. What do I do? Plus the 10 is the same as plus the 1. Plus the 1, right? When we look at it, Jay, let me find my little flippy thingy. So, is it 6? No, it's 6. Hold on. Hold, please. So, right? When we do it, it might be better if we did this. When we made it vertical. Does that make sense? If we make it vertical, focus on what it is. So here, if I want to plus the 10, I'm going to minus the 6 because the first place is the far to the right and the second column is the right to the one is the cents. I'm not sure about that. The ones place is the far to the right. No. Ones place is not far to the right. The second columns is the right of the ones. Yeah, the other 2 columns. So when we look at it, when we say plus 10, it's always going to be the 1 column to the left, if that makes sense. I meant the 3rd column from the right. Right. But see, when we look at it, it doesn't matter what, it doesn't matter which what the column, it doesn't matter where the column is. What matters is what you're doing to the column. Thank you so much, JP, for the rose. So does that make sense? It matters what you do to the column. So when we first look at it, we're looking at this. We want to add the 4. When we add the 4, there's not enough. So what do? We want to add 4 to this number. We cannot add 4, so we have to look to the next column. When we look at the next column, the next question is can I add a 10? Does that make sense? So when we look at it, so if I had my question, let's say I had 28. Let's do that. Let's do 28 instead. So I have a 28, right? I have 28 on my abacus. I have 20 and I have 8. When I look at it, I want to add 4. When I add 4, there's not enough, right? There's not enough to add the 4. I know my formula is plus the 10 minus the 6. So what I'm going to do is I'm going to look to the next one over. Plus the 10. So I plus the 10. Look at this 10, right? This 10 just means that. 0 and 1. I'm going to add the 1. and I'm going to take away the 6. Thank you, JP, for the rows. 32. Yes, 32. But does that make sense? So when we're adding it, we look at the first column. If there's enough, then you do it. If there's not, then you look at the second column. Okay. Hey, Mel, welcome back. So we're going to continue with this. We can do another one. Let's do another one. If then, yeah. If, yes. If there's enough, right? So I do 7. Let's do 7. So Destiny, we're going to do 7. We're going to add 7. When we add 7 plus 4, plus the 4, we want to add 4. 7 plus 4. We want to add the 4. There's not enough. If there's not enough beads, no, actually, if there's not enough beads, how can we do it, right? The first thing, because it's a 4, we want to look at the 5. Can we add the 5? No. Okay. Then, can we add the 10? Yes. Does that make sense? So for the 4, because if you notice, the reason why you have to be careful, because if you notice, when we add the 5, right, we have 1, 2, 3, 4. When we add the 5, these are the ones we can use. However, this, it depends on where we are. If we want to add the 1, we can also plus the 10 minus the 9. If we do the 2, we can either plus the 5 or plus the 10. Do you see how there's a thing? So then the next one is, if we have the 3, we can plus the 10 or plus the 5. So you have to be careful which one you're doing. You have to make sure which one you have. The question always, if the numbers are 1, 2, 3, 4, any of these numbers, you always have to ask if there's the 5. Can you do a 5? If not, then you do the 10. Does that make sense? So now, if I want to add 7 and I want to add the 4, I don't have enough. I need to, that's the if. Yes, exactly. Exactly. That's the if then. So what I want to do is, I have 4 minus the 6. Destiny, does that make sense? Using the 4's numbers, using the 5 first. Yes, exactly. Use the 5 first. So why do you know the 10 minus 6? So that's why it's a formula. Yes. Oh, so you have to know that 10 minus 6 is a 4. Yes, exactly. That's the formula. Why? Because I want to utilize this 10. If I add 10, that's too much. I'm only adding 4. So I need to subtract the 6. So that's the reason what we're doing is we're doing an exchange. We're doing a trade, right? We add the 10, but that's too much. So we have to take away the 6, right? It's overflowing. So we need to like cut it off. But yeah, so Jay, it's the first 4 numbers. Yes. When you're using the first 4 numbers, you want to check to see if you can add the 5. If you cannot add the 5, then you add the 10. Then it makes sense. Or else you go into a loop and then it doesn't make sense. Does that make sense? I say that a lot too. Does that make sense? Because it's hard to, yeah. That's the if then. Yes. If I have the 5, else use the 10. So if I had 3 plus 4, can I use the 5? Yes. So I stopped there. But if I had 8 plus 4, can I use the 5? No. Then I use the 10. It only goes up to 10. That's it. There's nothing else. Yeah. Yeah, it's crazy. It's crazy how simple it is. It's really crazy how simple it is. So those are the formulas. That's the secret to adding and subtracting. If you know how to do this, then you're gold. Because everything is scalable after this. You understanding the adding the 5, subtracting the 5, adding the 10, subtracting the 10. If you know how to make this all fit like Tetris, then you can add and subtract all numbers. Hello, Rolling P. Summers. Does that make sense? Right. So that's what it is. We can do some more. Why? Because if you notice, if we do stock, if we do stock, right? We have all of these for the tens. So that's what this is. If we want to add the 10, right? You can do 1 all the way to 9. We'll do 9 because 9 is an easier number to work with. But that would mean that we're going to plus the 10 minus the 1. So let's change our stock, what do you call it? Stock sentence, our stock addition, our stock, I don't know. I'm trying to figure that one out. I had another person that helped me about the beam. It's like beam me up. Beam me up is the adding, but then it's different when you want to. Okay. When we do this one, so we're going to do the 10. So that means we're going to add a 10. We're going to use the 10. Okay. Here is my 10. Now I have a 4. Notice this is another story. Right. Well, it's a story. I think it's a story. We have a 4. We add the 4 on the abacus. That's fine. We have the 4 on the abacus. That's great. Now we got to add the 10. I'm sorry, add the 9. Do we have enough beads to add the 9? No, we don't have enough beads to add the 9. Well, what is the formula to add the 9? The formula to add the 9 we know our stock, our stock sentence, our stock, what, fact family? I don't know if this fact family. I don't know. So what we're going to do is we're going to isolate this 9. When we isolate the 9, thank you for sharing my live, Lily. Yeah, now I'm trying to find my, yeah, there we go. What we're going to do is, let me know if anybody has any questions. What we're going to do is we're going to isolate the variable. Again, what we do is 9 plus 1 is equal to 10. Yes, thank you, Destiny. That's exactly what it is. So what's going to happen is I had my 4, right? Add my 4. The question is, do I have enough? No. I'm going to go to the asteroid. I'm going to go to the asteroids. That's what this is. That's supposed to be the asteroid belt. I'm going to go to the asteroid belt. I'll use 9, but I have to take away the 1. That's what that means. Welcome, Mel. Does that make sense? So then my final answer is 13. We'll do another one. We have this one, 3. So when we do 3, I have 3 on my abacus. And then again, what do? I plus the 10 minus the 1. See how it's the information gets compounded. What's going to happen is I plus the 9 is equal to plus the 10. So I go to the asteroid belt and I take away the 1. And my final answer is 12. Yeah. I mean, it happens again and again. And notice that there is a number pattern. It's going to be this, plus the 10 minus the 1. Now you notice there's the opposite, minus the 10 plus the 1. So we just built on top of each other. We have our one concept plus the 9, right? Plus the 10 minus the 1. And then now we can do the opposite. Welcome, Luz. Cool? Okay. I'm just waiting. So, because sometimes I hear the brain just splatters against, like, just kind of go. Because why? Because it's easy. Abacus makes it easy. Makes sense, right? Yeah. Welcome to the real world. I love that movie. Okay, that was The Matrix. Okay, so it makes sense. So even if we did 2, do 4 minus 5. 4 minus 5. I will do 4 minus 5. Hold, please. That's what this is. 4 minus 5. Oh, that's easy. Why? Because we have 5. That's 9. No, we don't do negatives. We do the other way. No, Mel, we don't do negatives. Because it'd still be this, and then if I just take away the 5, then it'd just be a -4. But you have to keep the negative in your head. Because how do you have a negative of a concrete thing? right? We don't do negatives on the abacus because it's only what is it called, whole numbers or positive numbers? It's either minus the 5, yes, as if it's not enough beads to make number use 10. Correct. Correct. So it's either plus the 5 minus the 5 or plus the 10 minus the 10. Yes, as needed if there's not enough beads to make the number. Yes, exactly. Exactly, Jay. Yeah, I mean, Mel, it makes, I mean, everybody is asking about, can you do a negative number? Yeah, I mean, you could, but it'd just be in your head, right? I mean, how do you minus concrete? Right? I don't know how you minus a house. How do you do a negative house? I guess is the question, right? I mean, if you really put it to like apples to apples, how do you have a negative apple? You can take away an apple, but you can't minus an apple. You can't have a negative number of an apple. Negative apples. Oh, so yes, and so the question is, Jay. So if our question is, let me have a question. I don't want to use this. I'm going to use this. Hold, please. Eat the apple. Right? Yeah, but I don't know. I didn't. Yeah. Anyways, so going back to the adding the 5 and plus the 5, adding that's all really. So when we start talking about two-step equations, right? Two-step equations is what it now it gets a little bit interesting. Now it gets interesting because when we start doing two-step equations, we know 7. We have the 7. We have 7. We added 7. Now we want to do is we want to add another 7. To add another 7, we know what? We know to add another 7, we want to plus the 10 minus the 3. We know this. We're going to plus the 10 minus the 3 plus the 10. Can we add the 1? Can we add the 10? Yes, we can add it. Now the question here is, can we minus the 3? Can we minus the 3 here? To add the 7, we use 10. Yes, we use the 10. But now the question is, can we minus the 3? No, you can't minus the 3. How? We can. How can you minus the 3? I don't know what just happened. Has been disconnected. They currently disconnected after 1 hour. Oh, all right. So, hello, Dean. I found you're live again on TikTok. Isn't it lagging? Yeah, I'm thinking it's not lagging that right now. So, what are we doing? We're doing is this. How do we know? Oh, interesting. Okay. Sorry. So we want to minus the 3. Yeah, we take away the 3. How do we take away the 3? Yes, Hennessy, that's what it is. Minus the 5. No, it's minus the 5. Minus the 5, because what we want to do is we want to take away the 3. To take away the 3, yes, Mel, that's what we're going to do. So what we do is 7 is equal to plus the 10 minus the 3. This minus is what we're trying to do. Minus means minus the 5 plus the 2. Does that make sense, Hennessy? So what we're not trying to add the 5, we're trying to subtract the 5. So this is a two-step. This is a two-step. Why? Because this, now we don't have enough beads. What do? We had to use another formula. If you look at it, if we did 4 plus 7 plus the 10 minus a 3, the question is do you see how simple? This is a simple subtraction because I have enough beads. So then what happens is, if I had 7, right, plus another 7, plus the 10, minus the 3, I don't have any beads to minus the 3, then I have to take it one step. I had to level it up and make sure that our 5 is working because there's no lollygagging. No freeloading numbers here, right? So we want to minus the 3, it's minus the 5 plus the 2. So this is what we do. And now if you see, this is this is the Tetris that we're doing. This can get more complicated. How can it get more complicated? Well, what if we had 47 plus 7? What? Well, 47 plus 7. We're gonna really know our numbers. This is the analytical thinking that we're talking about, right? So we have 47 plus 7. 7, I have 4, and I have 7. So what we're doing is we're doing multiple stuff. What does that mean? It's two-step equations. Yes, these are two-step equations. Because look, if I want to, I have 47, that's not a problem. Now I want to add the 7. When I want to add the 7, it is plus the 10 minus 3. Okay, fine. I'm going to plus the 10. Ha! I can't plus the 10. Now what do I do? I have to go back. Can you multiply 2? Yes, I can. We can do it after this. My son just woke up from his nap, so I'm heading out. Thank you. Not a problem. I'll see you later. Minus the 10. No, Hennessy, it's not minus the 10. It's add the 10. I want to plus the 10. So plus the 10 is add the 1. Can I add the 1? I want to be able to add the 1 plus the 1. This is where it's plus the 5 minus the 4. Put the 50 down. Yeah, so we plus the 5 minus the 4. But, Mel, we want to say 5. Right? We want to say 5. The reason why is because we're talking about the one column. If you start talking about 50s, hundreds, thousands, then the numbers get really big and unruly, and that's too much for me. I'm very simple. It's just that we just want to focus on the column. We only want to focus on the column. We only want to focus on this column. Can we add the 5? Yeah. See, if we added 50, then it'd be like this. And I'm like adding 50. I don't know. So we want to simplify, we want to strip away the complexities, right? We want to strip away the complexities because when we start talking about the big numbers like 50 and 40, then it gets too much for the brain. So now I added the 5 and I took away the 4. Okay, that's fine. But now I need to do the 3. When I add the 3, I'm over here. I want to take away the 3. Can I take away the 3? No, I cannot take away the tree. Wait, can you explain that? Oh, yeah. So my question is 47. And I want to add 7. I'm adding 7. I need to add the 10. Right? This is my formula. This is my modified formula, right? Plus the 10 minus the 3. So I want to do is when I add the 7, I need to plus the 10 minus the 3. Plus the 10 minus the 3. So if I line it up, I plus the 10 and minus the 3. Yeah, right? Makes sense. But notice I don't have enough beads to plus the 10. I don't have enough beads to add this 1. Because that's what the 10 means. 10 is just, the 0 is just a placeholder. The 10 is just like a placeholder. You know why? Remember when we do multiplication? Remember when you do multiplication and we had 7? And 7's a single digit. And what do? We go back a column. I don't know if you guys... Okay. Let me know if this makes sense. Then we did this placeholder. This is a placeholder. That's the same thing with the adding a 10. The adding a 10 is this 0 is a placeholder. Okay. I'll have to see if I can figure that out a little bit. I'm going to workshop that out again. So what's going to happen is if I minus the 10 or add the 10, I plus the 5 minus the 4. And then I take away the 3. I can't take away the 3. If I cannot take away the 3, what do? When I take away the 3, what do? I have to minus the 3 is equal to minus the 5 plus the 2. So again, this is just a bunch of plus 5 formulas. In the 10th place? No, not in the 10th. It's in the ones. Because the original question is plus the 7. So I have to minus the 3 here. Does that make sense? So what happens is I plus the 10 minus the 3. Plus the 10 minus 3. This is still the ones place. So when I do it, I minus the 5 and then I plus the 2. Yes, 54. Did that make sense, Belle? And Hennessy and Destiny and Jay. I don't know who else is here. Dean. Dean, are you still here? Hennessy. You can remember the place number by the dot on the line. Yes. Yes. Thank you, Dean. Yeah, I got it. Okay, yeah. So what is this? This is more, this is a lot of two steps, but this is essentially a two step. The reason why is because now we're taking this number and we're building, right? It's like the internet. We're build on top of each other. Like everything's connected. That's why it's called the web. I don't know if you guys know why it's called the web. Just so you know, the internet was called the web not because we like spiders. It's because everything is connected. So because the 10 is connected to, it's like the elbow is connected to the wrist bone, and the wrist bone's connected to the finger bone, and the finger bone's connected to the, I don't know. You know what I mean? Everything is connected. So what if it's 85 80 48 plus 7 because you couldn't do the 7? No, it's easy. No, if it's 48, it would be, there wouldn't be anything. 48 plus 7, right? Exactly. Then you don't need to. No, you couldn't. It's not you couldn't do it. It's then you don't need to do it, right? So if I had 48, I plus the 10, I'm still adding the 10. So I plus the 10 is plus the 5 minus the 4. But now the question is, can I take away the 3? Yes, I can. So I don't need to minus the 2, minus the 5 plus the 2. I just take it away. That's it. So my answer is 55. Yeah, right? So it's not the could, it's the need. Do you need to do it? It's all about being needy. These are great questions. I'm so happy. This is fantastic. Like this is fantastic. Yeah, and it's great when people see the connections. Hey, Caitlin, right? When you see the connections, you'll see how easy it is. And then there's all these strategies, that all the strategies you need is, do you know how to add the 10 and minus the 10? Do you know how to add the 5 and take away the 5? That's the only thing. If you give me any number, I can tell you how to work it with these 4 things. That's it. Any number, no matter how big, how long, how whatever, any number works like this. Let's do this one. Let's do this one. 9999 plus 7. Let's do that. Oh my God, what are we doing? 9999. 9999. We add 7. Okay. We want to add 7. We cannot add 7. What do? We plus the 5. I'm sorry. Plus the 10 minus the 3. Right? That's what we do. Plus the 10 minus 3. Well, we can, before, what we can do is minus the 3 first and then plus the 10. Why? Because there's enough beads to take away the 10. So let's take away, I'm sorry, there's enough beads to minus the 3. So let's take away the 3 first so we don't forget. Let's take away the 3 first so we don't forget. Now we're going to go here. We got to plus the 10. Well, what happens? We have to plus the 10. Well, remember, if I cannot minus, oh no, if I cannot plus the 1, which is what? Plus the 5 minus the 4. I can't add the 5. So what's my next one? My next one is plus the 1 is equal to plus the 10 minus the 1, minus the 9. So I'm going to plus the 10 minus the 9. Plus the 10 minus the 9. Well, let's minus the 9 first so I don't forget. And I'm going to plus the 10. Can I do it? Can I add the 10? No, I can't add the 10. What do? I do it again. I plus the 9. I take away the 9 and I plus the 10. Can I do it again? No. I cannot add the 1. So I minus the 9 and then I plus the 1. Now I am done. Does that make sense? So my final answer is 10006. Hey Gabby, welcome back. Did that make sense? So what we just did is we just did a bunch of repeating formula. So now if you look, yeah, right? So what happened is we didn't do a carrying over. We didn't do carry over like mainstream math, right? what did we usually do in mainstream math? We do like a carryover and we got to keep going, right? So if here there's not enough, so this changes to 10, right? And then this, no, that's not how we do it. We got to go, uh, no. So we did the 9, we did this, oh, we got to carry the 1, so the 1's over here. And then this is 0, and then 1 again, and then 0, 1 again, and then we'd have the 1, yeah. So I wish schools taught us how to use the abacus, but they don't. No, but that's my goal. So I need to memorize to add the 5. And yes, you do. You need to learn, memorize, add and minus the 5, plus and minus the 10. Yeah, 16 keeps the 6. Yeah, carry on the, yeah. Right. The abacus seems much more interesting. Yeah. Yeah. So the thing is, well, that's my goal. My goal is to try to make it more mainstream. That's why I talk about it like isolate the variable, substitution, making the 5, making the 10. There's a bunch of others. Oh, commutative property. What we just did here is commutative property. What does that mean? We can switch the two. So here in Abacus, we actually use this thing called commutative property of addition states that change the order of the numbers being added but does not change the sum. Cumulative. Commutative, yeah. Commutative property. And I'm like, how do these kids do this with their how do those kids do it with their fingers? They memorize the abacus in their mind. That's what they do. And to tell you the truth, it's a lot of practice. It's like playing the piano, right? You could play the piano by memory. You could play the piano just like you play an instrument. You play an instrument by memory. How do you play an instrument by memory? You practice. You got to do a lot of practicing. That's how they do it. It's exactly how they do it. It's exactly how they do it. As much as you practice the playing the instrument is as long as you practice how to do abacus, right? Until it becomes memory. Yeah, commutative property. But again, Abacus doesn't talk about all these technical math terms. But these are all mainstream math terms that I don't know why they do. Like we talk about distributive property. That's when my mind was like, oh my God, we do this in Abacus. So what is distributive property? Okay, we're done with this, right? We're done with the two-step problem. Now we can start going into multiplication and division. Why? Because in multiplication division, we start talking about distributive property, and then we talk about partial product and partial quotient. I'm like, what? Why can't we just work the abacus? That's it. So what are we going to do? We're going to do, so if you notice, if you think about it, we don't memorize anything higher than 9. 9 times 9 is 81. We only know this. We don't need to know anything higher than this. We don't need to know 23 times 7. We don't need to know anything. We don't need to know 12 times 12 because it's redundant. So what's going to happen is we're going to find our answer. Where are we going to put our answer? What we need to do is we need to count our digits. We have 1, 2, 3. We count our digits. Hello, Libby. So we know our answer is going to be right around here somewhere. That's it. It's going to be right around there. What does that mean? Well, now we're going to multiply it out. When we multiply it out, it's 7 times 2 is equal to 14. So I add my 1, and then I add my 4. And that's it. And then what do? Notice 7 times 3 is equal to 21. See? Can I add the 2 here? No, I can't. This is why you need to memorize your formulas. This is why you need to eat your wheats. Right? Wheaties? Mikey, he likes it. It's the Wheaties, Mighty Wheaties, whatever. This is why we need to memorize our formula. So we want to add the 2. To add the 2 to here, we can't. Plus 2 is equal to plus the 5 minus 3. So I'm going to plus the 5 and then take away the 3. And then add the 1. So my answer is, what's my answer? See, now we go back, right? In the beginning of the thing. Thank you, Destiny. Right? Yeah, that's what I'm saying. Welcome to the world. 6. Yeah. 1, 6, 1. Dean. Welcome to the real world, Dean. Yeah. So what are we doing? What we did is we multiplied it out, but we also still need to memorize. We still need to know our formulas. Because we know our formulas now, we could do everything. We could do almost everything under the sun. When it comes to arithmetic, only arithmetic. Somebody was like, "How do you do geometry?" I'm like, "Really? Geometry has nothing to do with arithmetic, right? It's about shapes. It's about like talking about angles and stuff. You could do like, I don't know. Thank you for joining. Hey, thank you, Alma. Welcome back. Um, yeah, I mean, trigonometry. What's trigonometry? It's about triangles, right? You don't really do arithmetic with algebra with a abacus. What else is there? Calculus. What is calculus? Calculus is about sine and cosine and the wavy thingy. You don't do that with the abacus, right? We're only talking about arithmetic. Add, subtract, multiply, and divide. That's all we're doing here. Everything else has their own set. Abacus is not the end all. Abacus is the gateway. Abacus is the foundation. When you get the foundation, then everything else becomes easier because you have like analytical thinking, critical thinking. Hold on, go back to the part we're on the 1 plus. Ooh, this one? This one? No, no, no. We had the 4. I'm sorry. No, no, you're right. You're right. You're right. It's 4. My bad. No, it's 1. 21. 21. Oh, 14. We had 14. So 7, 1, and 4. And then 2. We add the 2 because it's 21. We can't add 2. So what do? 2 plus the 5, take away the 3. And then plus the 1. And then we add the 1. That's what it is. We don't go 4. 4 was at the beginning. It's plus the 4 and then plus 2. Does that make sense? Yes, of course. Of course we could do another multiplication. Let me find. Okay, we got it. Yep. I did it. I did it again. I got lost somewhere. I just did it again. I lost somewhere. I must have cut the few steps. Oh, that's a good one. Okay, can we do an yeah, we could do it that one. You know what, we'll do another one right now. We'll do it right now because Amma told us. Amma told us. So Amma is pushing the class forward. So 18 times that by 12. First thing we need to do is we need to count our digits. We count our digits. 1, 2, 3, 4. Okay. 1, 2, 3, 4. So the first thing we're gonna do, and I'll stay with this color and then I'll change colors. So we have our number here. What's going to happen is we take this 1 over here and we only times it by this one. So we do the outside first. I guess they call it FOIL. I don't know why they do these things, but that's what they're doing. Oh, Gabby, so fun. Yeah, that's fantastic. This is what, that's what it is, right? Abacus makes math fun because it makes sense. Don't be scared. Don't be scared. Right? Oh, sorry. 1 times 1 is equal to 1. 1 is a single digit, so you go back 1 column. So I go back 1 column, I add my 1. First, outside, inside, last. But but see, it doesn't work here. She really helps a lot by going step by step. Oh, thank you. Yeah, I was trying to figure that whole FOIL out. We don't do last. We do left and then right. So 1, right? 1 times 1 is 1. So 1 is a single digit. I go back 1 column. Is FOIL only for 3 digits or 2 digits as well? It's the same. Then it's not FOIL. Yeah, that's what I'm thinking. Somebody said it's not. Somebody said it was FOIL. I was like, it's not FOIL when you do more digits. It doesn't matter. It doesn't. Yeah, because we don't do. We'll do this. Yeah, because in Abacus we don't do this. We don't do outside and then inside. We don't do that. We do left and then do right. That's what we're going to do. So let me do that. FOIL is for algebra. Oh, no wonder. Yeah. Okay, so what we're doing here is distributive property. That's what we're doing for sure. I know that for sure. So we do 8 times 1 is equal to 8. 8 is a single digit, right? 8 times 1 is equal to 8. 8 is a single digit. I go back one column and I add 8. Thank you, Alma. Yeah, that makes more sense when it's an algebra thing. Yeah, somebody mentioned it and I'm like, I don't think that's what it is. That doesn't really pertain to Abacus as much. So FOIL doesn't, FOIL doesn't pertain to it. Okay, we're done. No, we're not done. We finished the one column. So now what are we going to do? We're going to count again. I'm going to change colors. I'll do this color. So we count 1, 2, 3. 1, 2, 3. 2 times 1 is equal to 2. 2 is a single digit. I go back one column. Guess what? I need to add a 2. How do I add a 2? What are the steps? What are the questions we need to ask? We need to ask, can I add a 5? No, we cannot add a 5. Can I add a 10? Yes. How do I add the 10? 2 is equal to plus the 10 minus the 8. We cannot add the 5. Yeah, we have to do the 10. Plus the 10 minus the 8 because we cannot plus a 5. We cannot plus another 5. So that's why we use the 10. So we're here. Now it's 2 times 8. 2 times 8. 2 times 8 is 16. 16 plus 1 plus 6. And that's my answer. What's my answer? What's my answer? What's my answer? Ah, 216. 216. Yes. 5, 6. Yes, thank you, Amma. Yeah, 216. So my answer is 216. Make sense? See, I need to like move it around. But yeah. But I do it this way because if you want to see it big, you can change your phone. I don't know if I'm on your phone, but yeah, you could change your phone landscape and I get bigger. That's the reason. That's the reason why I do landscape. And I noticed I could do that. I was like, oh, this is much better. All right. We'll do another one. Are we ready for another one? I need to clean up. I have to clean up. I'm so messy. All right. You want to do another multiplication? We can do another multiplication. Multiplication seems to be like the one that everybody's really interested in. But I think, I think that adding and subtracting is underrated. All right. Okay. Alma says, adding and subtracting was fun. Yeah. Adding and subtracting, there's actually a lot of adding and subtracting like complexities, but I think it's a little bit underrated. And I don't know why, honestly, I don't know why we're trying to push the kids to do mental math. I don't know why. Like it's good to have this as part of your working memory. But I don't know why we have to do it in our head if we have we write out everything. So, anyways. So again, what are we doing? We are counting our digits. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So the first thing we're going to do is left to right. We go left. 1 times 3 is equal to 3. I would like to figure out percentages for sales. That's a division, right? Because once you get it in your head, then you know how to divide it. So we're going to have 3. 3 is a single digit. I go back one column, I add 3. So I add my 3. So then I go here, 7 times 1. I'm sorry, 1 times 4 is equal to 4. 4 is a single digit. I go back one column and I add the 4. I'm done with that. I'm going to change color. And I count again because I'm done with this. 1, 2, 3. 1, 2, 3. So now we're here. 7 times 3 is 21. I add my 2 and I add my 1. Can I add 2 here? I cannot add 2. So what do? Correct. What do I do if I cannot add 2? Thank you, Dean. Yes. Hold, please. Sorry. Hold, please. Okay. Yes. Skittle. Hey, Brian. Skill Abacus. You're absolutely right. Plus the 5 minus the 3. And then I need to add 1. I need to add 1 here. How do I add 1? Plus the 1 is what? Plus the 5 minus the 4. So then what do? I did 21. Now I got to do 7 times 4. 7 times 4 is equal to 28. I add 2. And then I add 8. Yes, thank you, Emma. What's my final answer? Survey says, answer, please. $578. Yes. Yes, it is. Absolutely right. Yeah. 578. Yeah. It all depends, like, how many people stay behind to really understand how to do multiplication and division. Yep. Do we do another one? We can do another one. I did it enough. I had enough space. So, but it gets easier, right? Because now we're understanding the basics and the fundamentals. Once you understand the basics and the fundamentals, then everything else is just about sequencing, right? Okay, we got 2. We got 13 times that by 95. And we have 52 times that by 36. Okay. It's this. It's the same. 1, 2, 3, 4. Okay. Nine times 1. We don't start with 5. We start with 9. We start with 9. Because it's the left, right? Just as we read, we always start with left. So it's 9 times 1 is 9. 9 is a single digit. I go back 1 column. So I went back 1 column and I add the 9. 9 times 3 is 27. I add, oh, you can't see it. Sorry. Add 2. I had 7. I add 2. There's not enough beats to add the 2. So there's not enough beats to add the 2. What do? Plus the 2. Can I add a 5? No, I cannot add a 5. So the next one is, can I add a 10? Yes. Plus the 10 minus 8. Plus the 10 minus the 8. That's the 2. Now I add the 7. Now I'm done with 9. Exactly. Now we do, we count 1, 2, 3. 1, 2, 3. 5 times 1 is 5. 5 times 1 is 5. Add the 5. 5 is a single digit. There's not enough. So plus the 5 is equal to plus the 10 minus 5. Plus the 10 minus the 5. And then our final one is 5 times 3. 5 times 3 is 15. I had 1. I had 5. So my final answer is 1, 2, 3, 5. Yes. So now we do this one. Same thing. We got to count it. 1, 2, 3, 4. 1, 2, 3, 4. We start with the left, right? We start with the left. 3 times 5. 3 times 5 is equal to 15. Add 1, add 5. 3 times 2 is 6. 3 times 2 is 6. 6 is a single digit. I go back 1 column, I add the 6. I'm done with the 3. I count again. 7, 1, 2, 3. 1, 2, 3. 6 times 5 is 30. I add 3 and then I add 0. I need to move and make sure that I add the 0. The 0, I need to make sure I keep the place value, right? 6 times 2 is 12. 6 times 2 is equal to 12. I add 1 and then I add 2. And what's my final answer? 1,872. Yes. Good. Thank you, Dean, Alma, Destiny. Does that make sense? I mean, it's kind of easy. But the biggest thing is like figuring out where to start. Yeah. I mean, and it's the same thing over and over again. It's just the biggest thing is, knowing your multiplication fact. Once you know your multiplication fact, then it's pretty good. there's a couple of rules. If it's a single digit, you go back 1 column and then that's about it. But again, it still goes back to making sure you know your fact family. Sorry, your formulas. You're adding a formula, your plus 5 and your minus 5, and when to use it, right? But that's why you go through like the course and stuff to understand like the process. Because right now we're just kind of jumping forward, but it takes time to understand everything. It takes time to make sure you know what you're doing, right? So, I mean, I just started going live. I don't know if anybody else has gone through Abacus, but it does take time. It does take time. It's not just a 1 hour kind of a thing, to really understand it. It's not just 1 hour because obviously I can breeze through it because I've been teaching it for about 20 years. It's a little different now because I'm trying to teach adults. Whereas before I was just teaching kids and I would just tell them to memorize the formulas. But now because I'm teaching adults, I want to make sure you understand why you're doing it. We need to understand why we're doing certain things because then there's no point of memorizing if you don't understand why. And it's all about language too. It's not could you do it? It's do you need to do it? Do you need to add 1? Do you need to add the 5? No, you don't need to add the 5. So, okay, do we want another one? You do a great job. Oh, thank you. No, thank you, Alma. Thank you for joining and having a conversation with me. It's just one of those things like I hope to be able to, get the worksheets out, the workbooks out, and just kind of, if something was ever to happen to me, Abacus will still live on. I mean, there's a bunch of people that do Abacus, right? But I mean, I know they don't Maybe we divide one. Yeah, we can divide one right now. Let's divide. Um, I know people that, you know, teach abacus, but they don't teach the way I do. I know that for sure. Thank you. We're going to do division. So when we divide, we're going to take our numbers and we're going to, what are we going to do? We got to have a conversation with our question. Oh boy. Okay. Okay, Emma. Let's do that. So this is our question. We got to finagle at something, right? 75% of 1245. We need to change this, right? To one. No, we got to change it to, what is it? 3/4 times that by 1245. Is that what we're doing? All right. So the first thing we need to do, okay, the first thing we need to do, we need to multiply this first. That's what we need to do. Does that make sense? Okay. Are we okay with that? We need to multiply it first. And then we will subtract. Then we'll divide it. Is that okay? Or do we do it a different way? What we could do, oh wait, or we do this way, right? Isn't it like that? And then what we need to do is we need to change our decimals like this. It's been a while. Because it's 40, right? So then we rewrite it. Then we go back to 75 divided by 1,745. What if you could find the fraction so easily, so if it could, like, 79? What if you could find the fraction so easily if it was like 79? What do you mean by 79? We actually don't need to do the fraction because we know 75 is a percentage. So it's a 0.75. We know that. So I actually didn't need to do fractions. Yeah, it could be 75. Yeah. Yeah. And so we take it into a decimal. I was just overthinking it because I don't do this very often. I don't do word problems very often. All right, so yes, and so what happens is because we have a decimal here, we need to decimal it out. We have to take the decimal out of the dividend. It's just like regular mainstream math. So then when we do that, we get to this, right? So we get this, and now what we do is we have our divisor and our dividend. So we have our divisor is 7, and our divisor is 75, and our dividend is 1,245. So what we're going to do is we're going to start setting it up. Whatever we do on one side, we got to do the other side. What we actually do is we do partial quotient. That's what we do. The first thing we need to do is understand where are we going to put our number. When we do it, we have to look at our dividend. How many digits is our dividend? 1, 2, 3, 4. Our dividend is 4, and we take away 2 divisors. 2 digits are divisors. Does that make sense? So 4 minus 2 is equal to 2. Do I have enough? 1, 2. Yeah, 1, 2. That's where my answer is. I don't have enough. I have to use my other abacus. 1, 2. Yeah, I have to use my other abacus. That's the one thing about that. It's just a little bit too small. Okay, so 1, 2. This is where my answer is going to be. Because this is where my answer is going to be. Hold, please. Because this is where my answer is going to be. My answers here, my dividend will sit here. We got to put our dividend here because we're going to do subtraction with the dividend. So it's 1, 2, 4, 5. We're not looking at place values. We're not looking at place values. We're looking at just placing them. Does that make sense? We're not looking at this as 10 12. We're looking at this as 1, 2, 4, 5. The first thing we need to do is find out who is bigger. When we look at it, we have our divisor and our dividend. We have our divisor is 7. We're only going to compare apples to apples, one digit with one digit. So 7 is my divisor. 1 is my dividend. Who is bigger? Seven is bigger. Because 7 is bigger, I'm going to utilize 2 digits. These are the 2 digits I'm going to use. I need to do 2 columns. So, thank you, Liz. So what's going to happen is 7 times what is equal to 2 digits. This is the 2. 1, 2. 1, 2. What times 7 is equal to 12 or less? 7 times 1 is equal to 7. So I add my 1 here, and I take away 7. Take away 7 from 12. Cannot take away 7. What do I do? Minus the 10 plus the 3 plus the 3 plus the 3 is plus the 5 minus the 2. I'm here. Whatever I do to the 7, I got to do the same to the 5. 5 times 1, 5 times 1 is equal to 5. 5 is a single digit, so I go back 1 column and I take away 5. Do I have enough? No. What do? Minus the 5 is equal to minus the 10 plus the 5. So I minus the 10 and I plus the 5. So I'm going to add my 5 here. And I need to minus the 10. I cannot minus the 10. What do? Minus the 1 is equal to minus the 5 plus the 4. Now, what do? Well, we still have our dividends. So our 4 is our dividend. Our divisor is 7. Who is bigger? 7 is still bigger. Yes, our divisor is still bigger. So we're still going to utilize 2 digits. These are the 2 digits, right? 7 times what is equal to 40. What is that? 49. 7 times 7 is equal to 49. So I add 7 here. I take away 40, take away 9. Whatever I do to the 7, I got to do to the 5. 7 times 5, 7 times 5, or 5 times 7 is equal to 35. This is where it gets a little tricky. Why 49? 7 times 7 is 49. Yeah, because we have 40 and we had 9. Why 49? Because when we compared it, that's what we got. We have 2 digits because 7 is bigger. So because 7 is bigger, we don't come back to here. We stay on our dividend here because we do things here. Why is it 49? Okay, let's okay, because we had 5 times 1 is 5. Okay, I need a bigger paper. I get it. I know why. I know what you're talking about too. Let's start over. 75, divide that by 1, 2, 4, 5, right? All right. We talked about, we know it's 1, so it's 1, 2, 4, 5, right? 2, who is bigger? Who is bigger? The 7 is bigger, right? Wasn't 7 bigger? Yeah. So we have our S and we have our E. We have our S and our E. Okay. So then 1. So we're going to put 1 here. We take away 7. Take away 7. So, okay. 12 minus 7, right? There's not enough to take away 7, so what do? Minus the 7 is equal to minus the 10 plus the 3. Minus the 10 plus the 3. Can we add the 3? No. Plus 3 is equal to plus 5 minus 2. Add the 5, take away the 2. Now, whatever we do to the 7, we got to do it to the 5. What were we doing? 7 times 1. 7 times 1 is equal to 7. That's what we did. So whatever we did to the 7, we got to do to the 5. So it's 5 times 1 is equal to 5. 5 is a single digit. I got to go back and I have to take away 5. That's where you get tripped up. Do I have enough to take away the 5? No. So what do? 5 minus 5 is equal to minus the 10 plus the 5. So I'm going to minus the 10 plus the 5. Let me add the 5 so I don't forget. I'm going to add this 5, right? Now we need to minus the 10. Can we take away the 10? No. Take away the 10 is what? Minus the 1 equals to minus the 5 plus the 4. That's why it's 49. Atticus, welcome back. Yeah. Yeah. But see, now we cannot look at up here because now it doesn't make sense. Yes, Atticus, I'm still talking about you. Right? So now what are we going to do? We don't look at this anymore because it's already on our abacus. When it's on our abacus, then we want to make sure that we stay here. It might as well be the whole channel about me. 6'7". Don't be 6'7". All right. So we all right? This is great. How she remembers names though. Oh yeah, I try to remember. Some people like kind of if you're not in often, then I kind of forget a little bit. But I try to remember your names. What does that make sense? So now what are we going to do? We're going to compare who is bigger. 4 was our dividend, right? Now our dividend is, now we got to look at our dividend. Our dividend is 4. And then our divisor is still 7. So we have, I'm going to change color. So we have 7 and then 4. 7 is still bigger. That's the joke. Abacus rhymes with. Thank you, Dean. Okay. So we still have that, right? So this is why it's 49. This is why it's 49. So it's 7 times what is equal to 49 or less? 7 times 7. 7 times 7 is 40 and then 9. Now, whatever we do to the, so 7. Whatever we do to the 7, we got to do to the 5. So 5 times 7 is equal to 35. 35. There's not enough. So now we have to do something with the quotient. The quotient is too big. We got to take 1 from the answer, and then we got to add the 7. That's what we're going to do. That's a rule that you just have to know. There's no other explanation about that. That's why this is about critical thinking. Can you do it? If not, how can you do it? So you have to take 1 from the answer, go back 2, and then you have to add the 7. So now the question is 5 times 6 is equal to 35. 5 times 6, right? Because we changed this to a 6 instead of a 7. So now it's take away 30, take away 5. So I take away 3, cannot take away the 3, minus the 5 plus the 2, and then take away the 5. That's going to be. So now we're still doing it, right? That's not making sense. Oh, I did it wrong. I'm supposed to be over here. Sorry. I'm supposed to be over here. Because this is 2 over here. So I'm going to move column over. I need to move the column over. That's more sense. There we go. Does that make sense? That still doesn't make sense. 75% of 12.45. Because it's 2. 1, 2. I hate this. Okay. Well, division seems complicated. It is a little bit complicated. It is a little bit complicated, especially when you start talking about decimals. 2, 1, 2. So, no, that's right. 6, and then we're back to here. 5. Okay. So let's continue on and see how it goes. That still doesn't make sense. Oh, maybe I did it wrong. 75% of 12. That's wrong. This is wrong. Oh, maybe I'm too tired for this. Fairly simple guy once you get to know me. Yeah, I'm doing that wrong. Wait a minute. Okay. So who's bigger? Okay, wait. I'm sorry. Who's bigger? That's bigger. So it's 7 times 7 times 1 is 7. 2, 4, 5. Wait a minute. Right? Take away 7. Sorry, that's a 2. Take away 7 is minus the 5, minus the 10 plus the 3. Plus the 3. Plus the 3. I'm doing something wrong and I can't see it right now. Take away the 5 because it's this right here. This is what's throwing me off. Our dividend, unless it's supposed to be the other way, but that doesn't make sense either. Is it the other way? No, that's too big. 75. I have to figure this one out. Okay. I will figure this out later. I don't want to waste everybody's time. Yeah, I think let me figure this out on offline, and then I will come back to it. You know what? If anything, I will make a post on it. I'll make a post on it so you don't have to be at the live. I'll make a post on this. But I'm doing something wrong and I can't see it right now. It's getting late. I've been on for about 2 hours, and I think that's when I start crashing, when it's about 2 hours. So yeah, you know what? Let me make a hey Babel. Let me make a post on it. Let me think about it and kind of regroup, and then I'll let you know. Cool? Yeah, but I think that's it. Are we crashing? I think we're crashing. I think we're finally crashing again. I will make a post on it this so. But thank you. I do appreciate this. There's something there and I can't figure out right now. Um, yeah, I think that's my limit. I think 2 hours is my limit. I was going to try to do a marathon, but I can't do it like on the spot. I'd have to go through my own workbooks if I want to do longer. Yeah, I don't know how everybody else does it. I know Audrey. I know Audrey. Sometimes she goes 3 hours. I'm like, holy cow, man, that's a long time. Yeah, yeah, because it doesn't make sense. Because I'm stuck somewhere. Okay, I know I'm doing. I know it's doing. Okay, but it is what it is. I'm going to take a little break. It was actually pretty fun to learn this. Oh, good, Destiny. I have to see. I have to go, but see you soon. Yeah, I'm gonna go too, Dean. I can't keep up right now. This question broke my brain. So, all right. Have a good day. Have a good night. Have a good evening, everybody. And I will see you guys in my next live. See you later. Toodaloo, kangaroo. Take a little break and recharge. Yeah. No, 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 no. You're perfectly fine. This is actually a really good quest for me because it's been a while. Have a good night. Have a good night. See you guys in my next live. Bye. Oh, yeah, I think this is wrong. Unless it's supposed to be the other way. 70. If I put here 75. Oh, I gotta end it.